Hello all, welcome to Code Hub. Consistency is the key to success. And come, today let's solve the LeetCode daily challenge. The question is minimum operations to reduce x to 0. And the question states that you are given an integer array nums and an integer x. In one operation, you can either remove the leftmost or the rightmost element from the array nums and subtract its value from x. Note that this modifies the array for future operations and return the minimum number of operations to reduce x to exactly 0 if it is possible. Otherwise, return 0. Okay. See the example 1. Here they are given the array and x is 5. So if we remove 1, then the x reduces to 4, and if we remove another one, the x reduces to 3. And if we cannot reduce this 4, so we can see for a possible answer that we can reduce the number from the rightmost index, and if we reduce 3, then the x becomes 0, and the optimal solution is to remove the last two elements. Wait a minute, I will show here. It's 1 1 4 2 3, and they have given x as 5. So if we remove the 0th index, that is this one, x becomes 4. And if we then the array is 1 4 2 3, and if we remove another one, then the x becomes 3. And if we remove the 3 from the then the array becomes 4 to 3, and if we cannot remove 4, so we can remove 3. So if we remove 3, the x becomes 0. X becomes 0, and the minimum operations that we get here is 3. But if you see here, if we remove the last element 3 from x, we get 2. And then the array becomes 1 1 4 2, and again if we remove the element 2 itself, then the x becomes 0, and that is what we need. We should make the x to 0. If such a case, then what is the minimum operation they are asking? So here we get the minimum operations as 2. So we should find the optimal minimum solution for this problem. And if we didn't get if we couldn't make any x to 0, then we should return -1 as of this question. Okay, hope so you can understand this problem. Let's think of an approach somewhere. Since there are possible solutions, that is, I can take either the first element, then the second last element, and again I can go for the last element, like that. There are many possible ways. Or I can take first two elements and then I can go and take the last element. So there are many possible ways, so we can think of some recursive solution, right? So if we write a recursive solution, how we can write? Okay, I will write a function which is going to return me the answer, return me the minimum operations. I will name the function as solve, and I will pass the nums array. What are all the parameters we are going to pass in that function? We should pass the nums array, and then we should pass x, so that we can see that x is becoming 0 or not. And we are removing either the leftmost index or the rightmost index in the array. Obviously we are not just doing a recursive solution, right? So we can just pass the index. So the first index and the last index, nums dot size -1. This is the leftmost index and this is the rightmost index. So I assume that this function is going to give me the minimum operations, and I will return the min operations. As simple as that. Okay, fine. Now we can just declare the function. This is a recursive solution where we are taking all possible ways. So this function is going to return me the integer value. I will declare an array vector int of nums, and this is the target x, and we should make the x as 0. Then this is the leftmost index, and this is the rightmost index. rightmost index, and that's it. Cool. What will be the base case? The problem states that we should make x as 0. So if x becomes 0, we can just return 0, right? Okay, yeah. If the base case will be x is 0, then we can return there are 0 operations, right? And there are two options. Either I can take the left index, the element which is at the left index, and I can take another option is I can take the rightmost index. How can we do that? If I take the leftmost index, consider this array. Consider the leftmost index as L, and here the rightmost index as R. And if I take this element, the leftmost index, the element at which the leftmost index, will be moving this L plus 1, right? This is what I'm doing. And if I take this rightmost index, if I take the element at this rightmost index, then I will decrement R, and I will move to the move to the next recursive problem, right? That is, I'm going to solve many sub problems. So that's what we are doing here. So I will call the function again, solve nums x, but you can see that when I pass the next x, then x will be subtracted with this element, right? They have given the solution. In one operation you can remove the leftmost or rightmost index, rightmost element from the array nums, and then it will subtract its value from x. So if I take the element from the rightmost index, then the x becomes x minus nums of rightmost index. And if I take the element which is at the leftmost index, then the x becomes x minus nums of leftmost index, right? So I will pass as x minus nums of leftmost index. And this leftmost index, what is happening? After picking this element, I will just move to the next element. So I will pass leftmost index plus 1, and I will pass the rightmost index as same as it is. What we are doing in the option 2, we are taking the rightmost index, the element which is at the rightmost index. So x will be subtracted with nums of rightmost index, and leftmost index will be as it is. This is a recursive solution. Hope you follow me. And rightmost index, once we take the element which is at rightmost index, rightmost index will be decremented by 1, rightmost index minus 1. What is the ultimate problem? We should return the minimum operation, so we will take the minimum of both these options. Is the problem over? No, we should take some of the edge cases, right? What if x becomes less than 0? We cannot pass x minus again, right? So we should pass some bigger value, so that the recursive call that we do at that particular point is not included. The recursive path that makes from that particular point is not included. So we should recur some maximum value so that it will not get included in our answer. And since the answer may get overflow, I will okay, I will return the int max. If I take this one option, I should account this to my answer, right? So I will add 1 to my options, both the options. This represents I have done one operation to do this. I have taken this element, so I have done one operation, and I will move to the next recursive call. And if I take this 3, I have done one operation, and I will move to the next recursive call, decrementing this rightmost index like this. That's what it representing. But if when x becomes less than 0, I am returning an int max, which is the maximum value of the integer. So what can I do here is I can subtract with some four nines, so that we can accommodate the integer we can accommodate it in the integer value itself. Once if we couldn't find any answer, then we should return -1, right? So if I get the minimum operations as greater than or equal to this value, then I can say that I did not get any minimum number of operations that makes x as 0. So I will return -1. Else we can return this minimum operations itself. Hope you can understand this recursive solution. Just we can run the code and see whether it is working or not. Yeah, it works. We can use the example test cases. Okay, but what will be the constraints? The constraints is nums dot length is 10 power 5 and nums of each element is 10 power 4. Okay, and x is 10 power 9. This I think this will not get executed. It will show a time limit exceeded error. Since this is a recursive solution, it is taking all possible ways. Yeah, it is showing a runtime error. Okay, this is what we expected, right? It will show a runtime error. Okay, we are getting a runtime error, but I thought of we will get a time limit exceeded. Somewhere we should handle some other base case, right? If x is becoming 0, we are returning a maximum value so that we will not take that path in our answer. Yeah, if what if the leftmost index crosses the rightmost index? Consider a case left and right are same, and if the left passes the right, then we should not consider that path as well, right? So if my leftmost index crosses the rightmost index, then also I should return a maximum value so that I should not take that path, and it will give a correct answer. We can just run this test case and see. Here, yeah, it gets accepted for this test case, and we can just submit it. Here, okay, yeah, we got time limit exceeded. We can convert this into a DP problem by caching the overlapping subproblems, but I hope we cannot cache also, since the changing parameters in the problem are x, leftmost index, and rightmost index. Will be needed of three-dimensional array, three-dimensional vector something, and we will cast that, and even you can see the x goes to 10 power 9. So I think there will be a memory limit exceeded, but for your reference I will show that too. Vector of int, this is a three-dimensional vector dp vector int of size n, and vector of int vector int size is n, and this is a dp array of three-dimensional size, right? Vector of int and n, hope so. Okay, hope so. Here yeah, here it is n comma vector of int, and here it is vector of int and n of vector of int, and here it is x comma -1. I am declaring the three-dimensional array with full of -1. We are caching it, right? So this should be up, and we will pass the DP also. I will just copy paste the three-dimensional array. should pass it by reference, and we should pass the dp here to dp of leftmost index, rightmost index x. This will be target to x plus 1, so we should get that also. Okay, if dp of leftmost index, rightmost index and x is not equal to -1, we can just return that value. Hope this will work. Let's run and see. Okay, n is not declared. Okay, int n is nums dot size. Here also we can just pass -1. Yeah, it gets passed. Now we submit it. We'll get a memory limit exceeded since it is more than the LeetCode provides. It is 10 power 9. Yeah, we will get a memory limit exceeded. 3-dimensional array, right? So that. Okay, this is the problem that we have approached in recursive solution. We have also converted it to DP, but if the constraints are small, it may work here. But this is a DP problem. I think no one will explain this DP approach since we are taking the minimum number of operations. We can approach it as recursive solution, but how we can optimize this? The time complexity here will be 2 power n. Since we are taking two values, 2 power, it will grow exponentially. So we should, the recursive solution is recursive brute force will be the recursive solution. Recursive, the time complexity will be order of 2 power n. And the space complexity will grow up to order of x. It will be n into x. So here we are getting memory limit exceeded and time limit exceeded as well. So we cannot do it in dynamic programming. Okay, let's observe something from this problem again. 1 1 4 2 3, and we are required to form x to be 5. We are required to make x as 0. What we can do here? Actually, we are removing the first two elements and last element. Then the subarray is, if we remove the first two element, so in this case I am removing the first two elements and the last element to make x as 0. So the subarray becomes 4 2, and the minimum operations here is 3. And consider I am removing the last two elements 3 and 2, then the x becomes 0. So the subarray will become 1 1 4, and the minimum operations here is 2. What it is doing? I can observe that the subarray sum is 4 plus 2 6, and here the subarray sum is 4 plus 1 plus 1 6, the same 6. But I am considering the largest length subarray so that the minimum operations is getting minimized, right? If I get a maximum subarray sum which is equal to some k value is nothing but the total sum minus x. The total sum minus x. Here the total sum is 6 plus 5, which is 11. 11 minus 5, we are getting 6. If I can find largest subarray which is equal to the sum k, then I can ultimately return the answers as nums dot size minus what I got the answer as, right? So we can do some sliding window technique where to find the largest subarray sum which is equal to k. So now we will go for a sliding window technique here. I will be needed of int nums dot size. In sliding window technique, we can just do some dry run so that you may understand what I'm trying to say. 1 4 1 1 4 2 3. Consider I have an I and a j pointer. Consider it as start and end. This is as start and this is as end. I will be moving the end pointer first with the sum. When I move this end pointer, I will calculate it to sum. So sum becomes 1, and I will move to the end pointer next, and now the sum becomes 2, and where I will move the end pointer to the next value, and the sum becomes 6. Whenever the sum is greater than x, we should contract the window. That's what we seen in the previous video, right? So our target is k, right? Target is k. Whenever the sum is greater than target, during that time we will contract the window, or else we will just expand the window and go. And now the end is moving to the next pointer, and the sum becomes 8. And as you can see that sum is greater than the target is 6 and the sum is 8, so we should contract the window. So start becomes I should decrement the element which is at the start point, so sum becomes 7. And again I will move the start point since sum is greater than target, and sum becomes 6. And now again I will move the end pointer next. Now the sum becomes 9. Now the sum becomes 9, and when the sum becomes 9, since sum is greater than target, I will move the start, and the value will be decremented, so 9 becomes 5. And we have seen we can do this technique, and we can find the largest sum subarray which is equal to the target. But the problem states that we should find the minimum number of operations to reduce x to 0. But we are finding the largest subarrays which is equal to the target, which is equal to target. So what we will do finally is the length of the array is n, and we will return the maximum subarray length. And this will give the minimum operations that we need to remove the element so that x becomes 0. And now we can just implement the idea: start which is starting from 0 and end which is starting from 0. And while n reaches the n, we should run this loop. We should have a sum which is going to calculate the running sum nums of n. And this inside the while loop we will increment the end pointer. We should have a sum variable in sum 0, and we should have a total sum so that we should calculate the target k. So int total sum is 0, or auto x in my nums. I will calculate the total sum plus equals to my x, and I should calculate the target as total sum minus x. This will give the target. But what if my total sum, we saw one test case, the total sum is less than x. If my total sum is less than x, we cannot make x as 0, so we can return -1 itself. Okay, now we can take the idea forward. Inside this we should run a while loop. Whenever a sum is greater than my target, I should decrement my sum with the element which is at the start index, start minus minus. That's it. And once I get out of this while loop, if my sum is equal to my target, then I should update my max subarray length as max of max subarray length comma end minus start plus 1. This will give me the maximum subarray length if my sum is equal to target, and finally I will return n minus max sub length, which will be the operator, which will be this. Okay, fine. We can just run the code now. Oh, I have not declared the maximum subarray length. Sub length to be minus 1. If my max sub length is minus 1, then I will return minus 1, since I cannot make x as 0, or else I can return the n minus max sub length as answer. Hope this works fine now. You can just run the code. We are getting a runtime error here. What is happening now? What is happening here? Okay, we have to contract the window. When we contract the window, it is nums of start plus plus, right? It should go to the next element. Now it will be running correct, I think. So yeah, let's submit this code. Nice, it works. And here the time complexity will be order of n and space complexity will be order of 1, since we have not used any extra space. Instead we will use just 2 pointer start and end. Hope you like this video, and let's see tomorrow. Bye.